the computer will continue to make boundaries towards infinity, and it will never end. You can get the computer to zoom in and continue to make boundaries and zoom in and continue to make boundaries. However, if you divide the space continuously towards infinity like that, you will never, ever, ever exceed that first boundary you made for yourself. So in the context of what appears to be a finite space, you can embed infinite amount of information. That's a very crucial understanding of the theory I'm writing. That is that space can be divided to infinity. If this is true, that means the atom can be divided to infinity. Each subatomic particle inside the atom can be divided into smaller one, into smaller one, into smaller one. That has a huge impact on the way we think about physics. For instance, if we understood this in physics, we'd probably stop building larger and larger accelerators to get smaller and smaller particles, because we know that it would continue to divide and we could just continue to build larger accelerator, and it's not going to tell us much about the universe. What we would look for is what is the fundamental geometry under which the universe divides. So here, I have an infinite amount of information embedded within the context of a finite system. So that means that every atom that you're made of currently could have infinity within them. That would mean each, that like subatomic particles that makes up the atom are all kind of mini black holes because they have infinite mass. And so infinite division probabilities. And so that changes your world. I mean, it changes your world in physics, but it certainly changes your world in philosophy, to understand that every point can have an infinity in it. So when I start to realize that, I realized that maybe the material world is not a function, meaning that it's not the material world that defines the space, but maybe it's just the space defining the material world. So it's kind of a reversal of our typical experience of the material world, of reality, thinking that matter does not define the space, but the space defines matter. And every time the space divides into smaller and smaller scale, it either makes a galaxy, a star, a planet, an atom, a subatomic particle, and so on. And when I did that, I started to realize if that's true, then there must be a fundamental geometry that defines the division of the space. And I started to look for it. And as I looked for it, it became self-evident that it had to be tetrahedral in nature. And a tetrahedron is like a pyramid with a triangle base. It's the smallest, most stable solid. And eventually I realized, that it must be not only tetrahedral, but it must be cuboctahedral. And that, as well is called a vector equilibrium. It's like 8 tetrahedrons put together collapsing towards a singularity towards the center. And when I realized that, I started to look around in nature to see if there was evidence of it. And I could find evidence of it many different places. And like Richard Oben and other researchers, I looked at planets because they're easy to see, and we have good data on them, and so on. So I started to look at planets, and sure enough, like Richard, I realized that there was very large energy events at very specific areas on most planets that mapped out the geometry of a tetrahedron embedded or enclosed into the globe or into the sphere of the planet. So, for instance, on Jupiter, the large vortex at 19.5 or 19.47, the sunspots on the sun keep appearing at those latitudes, north and south. The most active volcanoes on Earth in Hawaii, and so on. And so I started to say, to see like physical evidence of this fundamental geometry of the space influencing matter, how matter organizes to produce our reality.
I can see what you're saying with natural occurrence of the volcanoes, but when you go to the pyramids, which were made by an intelligent life form, didn't we have technology before that was obviously taken away from us because that happened thousands of years ago? And also, we chose the spot on the moon, I believe it was Sea of Tranquility, to be latitude 19.5 as well.
Yeah, there's a bunch of different things, but certainly when you look at the ancient civilization and certainly pyramidal structures that are found around the world, first of all, I want to clarify that according to my theory and what I describe in the mathematics of my papers, the geometry of the structure of the vacuum is more than just one tetrahedron. It's an array of tetrahedron, that creates cuboctahedrons. And when you look at the planets, the bands of the various levels on the planet, like the bands that you see on Jupiter, the bands that you see on Saturn and all this, they obey a much more complex geometry than just tetrahedral geometry, but actually array of tetrahedral geometry that defines very specific latitudes. And that confirms my model very, very strongly. Then, and people say, well, these ancient people talked about geometry as a fundamental structure of the universe, but they didn't build tetrahedrons, they built pyramids. Well, the cuboctahedron is an assortment of tetrahedrons and octahedrons, which are pyramidal. And that was crucial because maybe they were actually mapping the tetrahedral geometry using the octahedron cavities between the tetrahedron to create a resonance field, but that's a little bit more complex. So one thing is for sure, is when you look at these buildings and when you look at these ancient civilizations, there's a very large disparity between theory on how these buildings were built and the actual data. I mean, one example is the Grand Pyramid at Giza at 281 feet of altitude. The base of the pyramid is 13 acres square, and the apex of the pyramid, after having placed 2,300,000 stone, is still only a quarter of an inch off center after all the earthquakes that have occurred in 5,000 years. So they might have had it dead on when they built it. And this type of accuracy is nothing we could reproduce with all of our technology today. So something extraordinary must have happened. And the pyramid at Giza is only one example. There's many, many different temples and buildings all around the world that, really kind of raise eyebrows. When you actually look at the engineering and you look at the data and you don't just go with the archaeologic, theories, which is based on thousands and thousands, hundreds and thousands of slaves and vine ropes. And, you can have as many slaves as you want. When the accuracy and the engineering is past what we could do today, it's not a question of just brute force. It's a question of sophistication and advanced mathematics and so on, which these ancient civilizations did not have. So there's a great mystery there. And I think, and when I did my studies, I did studies in physics. I did a lot of studies in physics, but I did a lot of studies in ancient civilization at the same time. And eventually I realized that somebody else had done exactly the same. His name was